gone. So you guys should be on graphing equation slope day 1. We're going to talk about slopes, so let's not be doing our homework right now. Let's make sure that we are listening to our notes for today. Graphing equations slope day 1. All right, so let's talk about the evolution of slope. You guys actually talked about slope in 6th grade. Did you know that?
Yeah.
You did. Okay? It's kind of like stair steps, though. Rise over run. You guys had heard about that probably before I told you about it. That was something you guys learned in 6th grade. In 7th grade, this is what we're going to learn today. In 7th grade, we're going to learn that it's called the change in y over the change in x. Everybody say change in y.
Change in y.
Say change in x.
Change in x.
Yeah, so we're going to be figuring out the change in y over the change in x. What that means is we're going to look at the y values, see how they change. Right? If the y value goes from 3 to 8, what's the change in the y value?
5.
5, exactly. If the x value goes from -2, listen carefully, -2 to +4, what's that change? 6, right? So that would be like a slope of 5 over 6, because the change in y, Toby reminded us that was 4, or whatever it was, 5. And the change in x was 6. So we're literally just looking at the x's and the y's and how they change. In 8th grade, we're going to focus on those x and y's, and we're going to have an equation for it. That's actually an expression, not an equation. The equation will be m equals that, or m stands for slope. But that's the idea, okay? For us in 7th grade, this is going to be our slope definition, okay? Slope is, you should be writing this down, a ratio. Everybody say slope is a ratio. A ratio. Remember what a ratio is? Yeah, how do we typically write ratios in 7th grade? We typically write them as a fraction, you're right. So we write our ratios as fractions of the change in y, which is the rise, right? The rise is the change in the y's, to the change in x, that's the run. Between any 2 points on a line. Between which points? Any 2. So if I do the slope for these 2 points, and then I do the slope for these 2 points, what will I find? What if I do the slope between those 2 points? What about these 2 points? What about these 2 points? Those 2 points? What will I find? That the slope is what? Nope, the slope will never change. Okay? It is the ratio of change. It never changes. It is constant. In a linear equation, slope is constant. You guys may remember the unit rate, constant proportionality, how it was constant between all of those points. Slope is similar to that. Remember how we talked about how unit rate, slope, and constant proportionality were all the same for proportional relationships? It's not the same only for proportional relationships, though. So today we're going to see a bunch of examples where they aren't proportional, but they're still a slope. Because what is the slope a measurement of? What's the slope a measurement of? Something with a large slope. What does that mean?
With a large number difference.
Show me something with a large slope with your arms. Go. Show me what a large slope would look like with your arms. Yeah, what I don't see a lot of is this. Why?
Because it's supposed to be.
Because that's a small slope.
Yeah.
A large slope, I saw a lot of people going like this, right? A lot of people going like this. Large slope. So what does a slope measure?
Size.
Measures what? I heard it over here. Steepness. Slope measures steepness. Okay? So slope is constant because a line doesn't ever change its what? Doesn't ever change its steepness. Okay? So let's take a look at the kinds of slope that we can have. There are 4 kinds of slope that we can have. The first kind of slope, if we are checking left to right, because in English, how do we read? Left to right. So if we're looking at this left to right, what's happening to this line?
It's going down.
It's going down, so this is called a negative slope. What's happening to this line as you go left to right? It's staying flat, which means it's not doing what? It's not changing. It's not going up. It's not going down, which means it's not changing at all. So what slope is that? Zero slope. It's not changing. This one is doing what? Going up, so that would be a positive slope. And the last one is tricky. It's not a zero slope.
Positive two.
So because this is a zero slope, this one can't be a zero slope. Can you read this left to right? Why?
Because
Straight up and down. So we call that undefined. We'll talk a little bit more about why that's undefined, but here's how Mr. Baker remembers it. And I love this one. One of my favorite superheroes is Spider-Man, because he's your friendly neighborhood Spider-Man, right? He protects the neighborhood. Well, Spider-Man can crawl up and down buildings, but Spider-Man does not exist. Sorry, y'all. Spider-Man is pretend. This slope does not exist. We cannot define it. We'll talk about the real reason why it's undefined in just a moment, and it will make sense mathematically for you. But the way that we remember it is, Spider-Man crawls up and down buildings, but Spider-Man is not real. Sorry. So we can't define it. Okay. All right. A couple things we need to look at. So here is our general structure for us. We've seen this before, but I want to still go through it. Slope is the vertical change over the horizontal change. Remember, change in y over change in x? That's the rise and the run. Now, this picture made the slope triangle this way. That's how I typically make my slope triangles. I typically go up and down first, left and right second, because that helps me remember rise over run. Change in y's, do the change in y's first, put it over the change in x's. So we can figure out this slope, okay? What's our rise in this picture? What's our rise? 2. And what's our run? 3. It's 3. 1, 2, 3. As simple as do, re, mi, a, b, c. That's how easy love can be. Yeah, there it is. That's what I'm talking about. Luke, you can't be unafraid to sing it, brother. You can't be unafraid. But you are going to get hit in the head with a lifesaver. It was green. Now, what did I tell you? I told you that the slope is constant. So I want you to find it between another set of points. Ladies and gentlemen, yo, yo, yo. Yo, hey, thanks. Excuse me. Notice there's a point here and there's a point here. But there are other locations where I can get points. I want you to look at the picture in your graph, look at the picture in your notes, figure out another good place to put a point and put it there. Go. Look at the line, look at a good place to put another point. One that would make it easy to count to and count from. Hopefully you put it there. Why is that a good place? See?
Because it's not in the middle of the line, it's in between two.
It's right where there's an intersection of two coordinates. Remember how this is called a coordinate plane? Right? So there are coordinates that intersect there. And I told you that the slope is constant. Slope is the change in y over the change in x between what? What's your definition say? Between any 2 points. Let's check between those two. Look at the rise. What's the rise here? 2. And the run? 3. I thought it was between any 2 points. So what I want to do is I want to look at it between these two. Okay. What's our rise? 4. Huh. 4? And our run? 6. That's not 2/3. Oh wait, yeah it is. 4 over 6 is 2/3 simplified. So we can see that our slope is constant. It doesn't matter which points we compare. It doesn't matter which points we draw our slope triangles. It is constant. And the way we find that slope is you choose one of the points. Doesn't matter which one. Draw the rise. That's the up and down. Draw the run. Then write the slope as a fraction. Make sure that all fractions stay in fraction form. If this was 3 over 2, we would leave it as 3 over 2, not 1.5. Slope is always a ratio. Something over something. Rise over run, change to y over change to x. Okay? Questions for me on this? Okay, here we go. So let's take a look. Positive slope goes
Up.
up from left to right. Up from left to right. The rise and run must both be in the same or positive directions. Or the rise and run must both be in the same negative directions. What I mean by that is, follow me on this. That dark line, if the rise goes up, then the run must go right. You can also measure it by drawing down and left. Why does that work? Well, let's take a look at this graph, okay? Let's find the slope of that dark line. Let's draw up and right first. So you pick 2 points, here they are. So it goes up how many? 2. And right how many? 2. So the slope is 2 over 2, which equals 1. So our slope is 1. Now I want us to do the same thing by drawing down and left. Let's see if it works. This little green line that I just put on here, that's going down. So that's not 2, that's negative 2. And then to the left, what's that? Negative 2. So if I have a slope of negative 2 over negative 2, what does that simplify to? Oh, I'm so sorry for you. Oh, I'm so sorry for your lack of singing that all of you didn't do. See, right? What do we got, Tobias? What do we got? Same sign positive, different sign negative. Do you see any different signs being divided here? No, same sign positive. So we got positive. So no matter what, no matter if you measure up and to the right or if you measure down to the left, it's going to yield the same slope mathematically, right? The way that you can remember that is it's going up. We always read left to right, it's going up. Negative slope, on the other hand, goes down from left to right. Negative slope goes down. And it's important that you'll notice that one of these, either the rise or the run, will be negative. These will always be opposite signs. So you can draw, if the rise is up, okay? If the rise is up, then the run will be negative, will be left. Okay? If the rise is down, then the run will be right. No matter what, with a negative slope, the only way to get a negative slope is if the numerator and denominator are different signs. Right? Because if they're the same sign, what's it going to be? Positive. Different sign, negative. So we have to know that when we have a line that goes down, that either our numerator or our denominator has to be negative. So let's check that out here. Let's look at the red writing first. If the rise goes down and then to the right. That's typically how I do it. So if I'm going down here, what's my rise? Negative 2. Why is it negative 2? Because I drew down, right? Negative 2. And then my run? Positive 1, because I'm going to the right. This is where it gets a little tricky, so that's why I really want you to pay attention on this one. Why is it negative 2? Because I drew the line down. Why is it positive 1? Because I drew to the right. And right is in the positive x direction. Now let's look at this in terms of the green. Let's draw up. If I go up, I'm going positive 2. And then, to get to my next point, where do I go?
Left.
Left 1. Left is which? That would be negative, right? Negative 1. What's 2 divided by negative 1? Same sign, positive, different sign, negative 2.
So it'll be -1.
Notice how no matter how you get the slope, it's going to be the same value. Going to be honest with you, I usually use the red version. If I go down, it's negative. Can I be real with you though? I'm going to be honest with you, I rarely put negatives and positives here. I think about these as distances. What I do is I look at the line and I say, is it going up or is it going down? If it's going down, I put a negative sign in there. If it's going up, I don't. So the way that I actually do this, I don't do negative 2. I see this as a slope of 2 and 1, but it's going down, so it's negative. So if that makes more sense to you, just look at the line, decide if it's positive or decide if it's negative, then do that. Don't worry about these negatives. If this makes more sense to you, all right, I'm drawing down, therefore it's negative 2. This is how my wife does it. My wife's a 7th grade math teacher at Dolesville. This is how she thinks about it. And it's okay that we think about things differently. For me, I look at the line and I know it's negative. For her, she draws her slope triangle down and right, which means it's negative and positive. Same sign, positive, different sign, negative. Okay, so whatever way clicks for you, that's what I want. That's how I want you to think about it. Okay. Questions for me before we get? So these 2 are the tricky ones. All right. These are the ones you encounter a lot more often. Positives and negative slopes. All right, let's get to 0 and undefined. All right, a 0 slope is a what kind of line? So that's good, but all lines are always straight. Every line in the history of lines. 0 slope is a what? A flat line. Okay, we're getting closer. Yeah, Steven?
Horizontal.
A horizontal line. We want to think horizontal because there's a really easy way to remember this stuff, which we're going to get to in just a second. The numerator is always 0. The numerator is always 0. Why? Because it does not go up or down. And what's 0 divided by any number? 0. So the slope of this number is 0. So what we say is, all right, the rise is 0, right? Because it doesn't rise. It doesn't rise, right? And the run, well, do you guys know what that symbol means? Infinity. It runs forever, right? It doesn't ever, it just runs forever. It runs forever. That's infinity. So what is our slope for a horizontal line? 0. I'm going to let you know, the way that we remember this is, it's called HOI. HOI. So HOI stands for horizontal line, 0 slope, y equals. You'll see the equation for this line. Brenna, wake up. You're not taking notes, though. Join us. Horizontal line, 0 slope, y equals. The equation for this line that you see right there is y equals 3. Because where is it located? At 3 in the y, right? That's the equation. HOI reminds us that a horizontal line is a 0 slope and it's y equals. Okay? Undefined slope. Why do we call this undefined? Undefined slope is a what kind of line?
Middle line.
It's a vertical line. Now, why is it undefined? Well, the run, does it run at all?
No.
No, the run is always 0. Which means that the denominator is going to be here, because it doesn't run, right?
Divided by 0 is 0.
No. Any number divided by 0 is undefined. Why is it infinite? Because what's it do? What's the rise? It just keeps going. It rises infinitely. It rises forever. So here's the deal. Can I divide something into 0 groups? All right, Jason, I'm going to divide you into 0 groups. Can I do that?
You can destroy it first.
No. Even if I do that. That's the only way we can do it, right? If I have the Infinity Gauntlet, I could divide people into 0 groups. But I'm sorry. That's Marvel Cinematic Universe, not the real cinematic universe.
Hey, they have a helmet that you can use it.
I believe it. In this real world, we can't divide things into 0 groups, right? I can take nothing and I can split it into a bunch of groups, but I can't take this and literally make it not exist anymore. I can't take this and make it not exist. I can split it into 2 groups, or I can put it back into 1 group, but I can't put it into 0 groups. Does it still exist? Yes, it's just on my podium.
Hey, it's on the floor.
Does it? I made it disappear. Oh, oh no, it's just on the floor. Okay? So I can't, you can't split something into 0 groups. That's why it's undefined. So what's the slope of this vertical line? Undefined. The slope is not 0. Guys, hey, what's the 0 slope look like? What's a 0 slope line look like? Okay, stop saying that that's a 0 slope. Is this a horizontal line? It's not a horizontal line. I literally wrote down it's a vertical line. We literally wrote down that it's undefined. Undefined slope. Stop saying it's 0. It's not. Any number divided by 0 is not 0. We literally just explained why. Okay? The way that we remember this one is Vux. So, we've got Hoy and Vux. This helps us remember. Horizontal line, 0 slope, y equals. Vertical line, undefined slope, x equals. What is the equation for this one? X equals 3. Because y is nothing, right? Y is infinite. So Hoy and Vux. Hoy helps us remember horizontal line, 0 slope, y equals. Vertical line, undefined slope, x equals. Okay. A couple of questions. What do we got? Questions on these 2? All right, we've got 4 sample problems that you are going to talk about with your neighbor. Of course, these are not in your notes, so you are going to look at the screen, you are going to talk them over and figure out the slopes with the person next to you. I'm going to give you about 1 minute. I think that should be plenty of time to look at these and write down some slopes, okay? So, actually a minute and a half. Minute and a half. Talk through these with your neighbor. Get all 4 of them down. Stop working on your homework. Do these. Talk them over with your neighbor. Figure out what these slopes are. Simplify your slopes. That's fine, Chris. You can do that. Get those slopes. Be talking about them. All right. Okay, so top 2. Positive, negative, right? Okay. What's the slope of the first one? What was it? 5 over 1. Outstanding. What's the slope of our second one? What's the slope of the second one? Positive or negative?
Negative.
It's definitely negative. What's the slope? Everybody?
3 over 5.
Almost.
Negative 3 over
Negative 3 over 5. Good. What about number 1 here? Why is this one a little trickier? What's not on this graph? No dots. So what should you do?
Make your own dots.
Make your own dot. So I would make a dot here and make a dot there. That's what I would do. It ends up being 4 over 5. Okay, 4/5. And here, I make a dot there, a dot there. It ends up being negative 3 over 5. Okay? Questions? Let's do the last problem on the notes. This is putting together everything that we've done so far. Okay? So when I do my work here, I have y equals negative 2 parentheses plus 1, right? Y equals negative 2 parentheses plus 1. Y equals negative 2 parentheses plus 1. Hey, look at that. What is yours?
0.
Yeah.
Cool. Change it to negative 1, 0, 1. Maybe you should have just stayed with me in the notes. All right. So I plug negative 1 in, plug 0 in, and I plug 1 in. And I get positive 2 plus 1, 3. Negative 2 times 0 is? 0 plus 1 is? 1. Negative 2 times 1 is? Negative 2 plus 1 gives us negative 1. So our ordered pairs, negative 1, comma 3, 0, comma 1, and 1, comma negative 1. Now let's plot those points. Negative 1, 3. Oops, that's in the wrong spot. There we go. Negative 1, 3. 0, 1, and 1, negative 1. We graph the line, you use a straight edge. I can't because I'm using my tablet. Remember, the line goes all the way through. There, now you can see a little bit better. And now it's time to get our slope. We can pick any of the points that we want. What can you tell me about the slope right away? Just like, give me something. It's negative. We can tell it's going to be negative. So I'm going down 2. That's negative 2. And over 1. Giving me a slope of negative 2. For those of you who are a little more advanced, I'm going to just give you a little hint here. There's my hint.